Hello, good afternoon, everyone again. Very good afternoon. I'm just waiting for all of you to join. Good afternoon, everyone. Welcome everybody to this session. Okay, let's get started. I think some of them are not getting the link, so just wait a second, folks. Okay, great. Welcome everyone. So today's session we'll be specifically discussing about few important concepts in differential equations, and we try to apply that to some of the frequently asked models in the exam. All right. Welcome Surya, Harish, Kathy, Devil's Cry, Govardhan, Suraj. Warm welcome to everyone, and I think others are also joining. Welcome to Spark Academy. You can download our app. Lot of free study material is available. We also conduct live classes. We also conduct assignments, quizzes, chapter-wise tests, grand test, everything. You can check out our store. We have admissions open for various courses. Now, coming to today's topic. Today's topic, we will be discussing about solving a differential equation. Solving a differential equation. For solving a differential equation, you have some methods. So I'll directly dive deep into the methods. The first method is variable separable method. Variable separable method. So what we do in this is, if suppose the differential equation is of the form dy by dx is equal to some function of y by some function of x. So how do you do it? Basically what we do is we separate all y terms and we separate all x terms and integrate. So what we do is all y terms, so dy by f of y I'm taking, that is equal to dx by f of x basically. So what we are doing is we are separating all the y and x terms such that dy and dx both are always there in the numerator only. And after this, you just need to integrate. So integrate dy by f of y is equal to integral dx by f of x. So we use some basic integration formulas to get the solution easily. Is it clear, everybody? All of you? Yes, I'm reading your comments, please. So far, so good, everybody. So what you need to do is, if suppose it's in separately y and x, you just need to take all the y terms on one side and you need to take all x terms on one side and then just integrate them. You'll get the answer. Right? So this is the first method which you need to know. Weightage 4 to 5 questions. 4 to 5 questions you get in differential equations, please. One of the very important topics. So the second method is homogeneous form. So suppose you have the differential equation dy by dx as some function of x comma y, and here also denominator also is a function of x comma y. Right, everyone? So what is the difference between this method and this method? Here it was y separate, here it was x separate. Now here you have both x and y are together, but they are homogeneous. What do you mean by homogeneous? Homogeneous means the degree of each term is same in numerator as well as denominator. The degree of each term is same in numerator as well as denominator, then it is said to be in a homogeneous form. Right? Everyone? So when you are having this, what you need to do is, to solve this, you assume y equal to vx or x equal to vy depending on the question. They might give dy by dx or they might give dx by dy also. So if you have this, if you differentiate, what will happen? Dy by dx. And how do you differentiate two terms? We learned in differentiation that this is like UV rule. So u into derivative of x is nothing but 1 plus x into derivative of v is nothing but dv by dx. Same thing, here you are differentiating with y. So dx by dy will be v plus y dv by dy. So what you need to do is, you just need to substitute back this in the original expression and then separate using variable separable method. So the only extra step which we are doing in homogeneous is, we are giving y equal to vx and we are differentiating on both sides and we are substituting back in the original expression. In that I am giving y equal to vx and I am giving this. Once you do it, you will be able to get it in homogeneous form, is now converted into variable separable method. So the last step is variable separable. You know how to do variable separable. We already learned that, which is separating y terms, separating x terms and integrating. I want some energy in the comments, guys. Is it clear, everybody, so far? So we learned two methods to solve differential equations. The first method is variable separable, which is we are separating variable x and y separately and we are integrating. The second is homogeneous. How do you identify it as homogeneous? The degree of each term in the numerator and denominator is same. So you need to assume either y equal to vx or x equal to vy, depending on the question, differentiate on both sides and substitute back. Right? So we'll do problems so you'll be able to, get more clarity. So why I'm discussing all the methods is, in the exam they won't tell you, which method to use, right? They won't actually tell you which method to use. So you need to figure that out. So that is why I'm explaining the methods. Then, when we do problems, you'll be able to understand better. Now coming to third and the last method which we learn in this topic, right, is the linear differential equation. Solving a linear differential equation. So what is a linear differential equation basically? What is a linear differential equation basically? If you have differential equation in the form dy by dx plus p into y equal to q. So it is in linear form. Basically, it's a first degree differential equation. You have something like this, where p is nothing but p of x. It's a function of x. Q is also a function of x. So if you have this type, there are two steps. First step is you need the integrating factor, which is nothing but e power integral p dx. And next step is the solution, the general solution, which is y into integrating factor is equal to integral q into integrating factor dx plus c. So you are first identifying whatever is that p, whatever is that q, and you are first identifying, you are finding the integrating factor. Once you do the integrating factor, substitute it in the general solution formula, you will solve the differential equation. Now same process, if I have dx by dy plus p into x equal to q. Same process, but here p will be in terms of y, q also will be in terms of y. So you'll get integrating factor as e power integral p dy basically. And the solution will be in terms of x, which is x into integrating factor equals to integral q into integrating factor dy plus c. Is it clear, everybody? So these are the three fundamental methods which you need to understand to get any, solving differential equations question. Am I clear? Everybody? All of you? So one is variable separable. When do you use that? If you're able to separate x and y easily. Second is what? Second is homogeneous method, which is if degree of every term, both x and y are combined, but the degree is 2, 2 or 3, 3, every degree is same, you assume y equal to vx or x equal to vy. Third, if it is in dy by dx plus p into y equal to q or dx by dy plus p into x equal to q format, you first need to find out integrating factor and then find out the general solution. So if you follow these three methods, you will be able to follow any sum. And of course, stay tuned to this video because I'll also be showing you a trick to solve any differential equations question as well. Alright, so we have discussed the methods. So we have 2021 as well as 2022 batches. Admissions are also open. You can contact the numbers given below or you can download the app and we will reach out to you depending on your requirement. So please refer it to all your friends as well. Varma will be doing all problems based on all the methods, so don't worry. First question. So the solution of this is, the solution of dy by dx equal to x minus y by x plus y is. So can you tell me, can we use variable separable method? So three methods we know. Can we use variable separable method, folks? Is x and y separate? No. No, right? We can't use variable separable. Not possible. Not possible. So first method I can't use. Second method, homogeneous. Homogeneous means x and y are together. Yeah, they look together. So what should I do next? If they are indeed together, I have to find out the degree. The degrees are 1, 1. Yes, correct? Everybody? Yes. This is in the form of homogeneous. So if it is a homogeneous, I can assume y equal to vx. So dy by dx equal to v plus x dv by dx. So how can I write this now? V plus x dv by dx is equal to x minus y is nothing but vx again, x plus this is also vx again. So x everywhere cancelled, everybody. So how do you solve this equation now basically? So let me solve this. So v also I will take it to the other side. So I'm getting x dv by dx equals to 1 minus v by 1 plus v minus v basically. So what will you get now? X dv by dx is equal to, if you simplify, 1 minus v plus v square whole divided by 1 plus v I'm getting. Correct? Everybody please? All of you? Now if you're observing, all v terms are on one side, all x terms are on other side. So if I rearrange, what will I get? Dx by x is equal to, this is nothing but 1 plus v by, this is what? 1 minus v minus v square basically. This is 1 minus 2v minus v square basically. So now, and into dv I can write. Basically I'm sending this here, I'm sending this here. Right, everyone? So when you are doing this, what next can we do here? We have separated v variable, we have separated x variable. So I just have to integrate on both sides. So what is left is integrate on both sides. So if you are integrating this, you know integral 1 by x is nothing but log x. And for this, you know that if this is f of v, denominator term 1 minus 2v minus v square. If you just differentiate it, what am I getting basically? If you just differentiate it, derivative of 1 is 0, derivative of minus 2v is minus 2, derivative of v square is minus 2. So you are getting minus 2 minus v, or if I take minus 2 common, I will be getting 1 plus v, right? Everybody? All of you please? Can I have some answers? Can I have some comments, guys? Let's not make this session boring. Please keep on commenting. Do you have any doubts so far? What have I done? I've given y equal to vx. I've put it in the question. And I've differentiated on both sides. So then I've got separated v, separated x. So then I'm trying to figure out how to integrate this. So you are observing numerator 1 plus v, but this is minus 2 times 1 plus v. So can I multiply with minus 2? Can I divide with minus 2? Everybody? If you do that, this is like f dash v by f of v. That formula is log of denominator, which is log of 1 minus v square minus 2v minus v square, and this is minus half. So we got the final differential equation. Now what is this happening? What is happening here? This is in terms of v. So what is the only thing which we need to do? We need to, substitute. What did we assume? Y equal to vx. So v equal to y by x basically. So instead of v, you substitute y by x. Log will get cancelled. Simplify, you will get the answer. Got it, everyone? All of you? Everybody? So this is how you do homogeneous type of question. Step 1, we are doing this. So I'll write it steps for you. Y equal to vx. Then, you are just differentiating on both sides and substituting in the question, taking all v terms on one side, and then using the general integration form, you are getting the answer. So very easy, homogeneous type. This you can see previous EAMCET question. Dy by dx is equal to y plus x tan of y by x. You can't separate y and x. So which is the best way, guys? If you actually do one more step extra, you are getting dy by dx equal to y by x plus x tan y by x basically. So again, if you observe this, 1, 1, 1, 1, again homogeneous, right? So again it is homogeneous. Again I can assume y equal to vx. Again, I can say dy by dx equals to v plus x dv by dx. I can substitute that. So I can say v plus x dv by dx. Y equal to vx, so vx by x I can write. Tan of y by x is vx by x, again I can write. Now observe, v cancelled. So I am getting x dv by dx is equal to 1 plus tan x. So if I want to simplify this, I can write dv equals to 1 plus tan x by x dx I can write. Correct? Everybody? Anything else is there? V plus x dv by dx I've written. Here x and x got cancelled, so we got tan of y by x. So here also v got cancelled. Actually, this completely got cancelled, no? So this should be 0 actually. Right? So this is what we can do. Now if you integrate on both sides, you will be getting the answer, right? And then you need to substitute back that v, so you know all that. Is it clear, everybody? All of you, please. So this is again homogeneous, very simple to solve. So what have we done? Y equal to vx I have given. Dy by dx is v plus x dv by dx. So this is v actually. V plus x dv by dx. So I have substituted here. So this is v plus x dv by dx. So y is nothing but vx everywhere. So here I can write vx by x. So we got v tan of vx by x. This is tan x. V directly got cancelled. Acha, this is x and x, right? So this is tan v actually. Yes, this is tan v. So you will actually get here. Dv by tan v is equal to dx by x. Yeah, now it's easy to simplify. Integral cot is log of sine. This is log x plus c. Nothing else is there. So log will get cancelled. This is like log c, so you'll get cx probably. So simplification is easy, but identifying is the most difficult step. Is it clear, everybody? So you know we are able to do homogeneous now. Homogeneous part is easy. Now what about this case? Can you tell me now? I'm waiting for comments. Then only I'll start my question. Dy by dx plus y tan x equal to cos square x. Which method should we use? Can we have method 1? No. I can't use method 1. I can't separate y and x. Is it homogeneous? This is square. This is 1. This is 1. I can't use second. So which method should I use, folks? Which method should I use? Can I use method 3? Everybody. All of you. Can I use LDE? Everyone. Comments. Can I have some comments, folks? Can I use linear differential equations? Aradhya, I can't use variable separable because y and x are together. So I can use linear differential equation. So can you tell me how this is looking like? This is looking like dy by dx plus p into y equal to q. So what is my p here? P is nothing but tan x. Q is nothing but cos square x. Right? Everyone? Yes. So first I have to find out integrating factor. How do you find out integrating factor? E power integral p dx. So e power integral tan x. Integral tan, you know, log mod secant x. So e and log will get cancelled. Integrating factor here is secant x. So what is this general solution? Y into integrating factor equals to integrating q into integrating factor dx plus c. So y into what is integrating factor? Secant x plus integral q is nothing but cos square x into secant x dx plus c. Secant and square will get cancelled. Integral cos is nothing but sin x plus c. So basically we will get final answer as y secant x equal to sin x plus c. which is fourth option. Is it clear, everybody? So LDE, what are my steps basically which I'm doing? I'm first identifying that it is LDE. You're getting P and Q, finding the integrating factor which is e power integral PDX, and then finally substituting in the general solution. Very simple. This is a sure question in EAMCET as well as JEE. One question based on LDE you can expect, please. So I think one of you asked me to solve one question, so here you go. Is it clear, everybody? So LDE is also actually very simple. You just need to give, you need to identify what are P, what are Q, you are done. The rest is simple. I hope all of you are following and enjoying this session. So far, we have done homogeneous type, we have done an LDE type of question also. I'll come back to the fourth question at the end. As I told you, I'm going to teach you another special method also. What about fifth question, guys? What about fifth question? dy by dx equals to under root of 1 minus y square by under root of 1 minus x square. So if I just do a simple calculation, I'm getting minus under root of 1 minus y square, under root of 1 minus x square, right? So can you tell me which method can I use? Everyone comments. Everybody should comment, please. Then only you'll enjoy and appreciate the session better. So can you tell me which session, method can I use here? Which method? Which method, please? Which method can I use? Which method can I use? Y and x are separate. So I can use a variable separable method, right? Everybody? So take all y terms on one side. So minus dy by under root of 1 minus y square equals to dx by under root of 1 minus x square. Yes, everyone? Yeah. So dy by under root of 1 minus y square is equal to dx by under root of 1 minus x square. So you integrate. This is the formula of sine inverse x. Sine inverse y basically. And this is the formula of sine inverse x plus c, or you take it to the other side, you'll get sine inverse x plus sine inverse y equal to c. Got it? First option is the final answer. Very, very, very simple. You just separate y terms, separate x terms and integrate. You will be getting the variable separable based question as well. Now finally, there's also a solution passing through 1, 1. This is interesting. So please pay attention. These types of questions are also asked. Very good, Vivek, Meghna. You have got it right. So now can you tell me x dx equals to minus y dy. Again, I can use variable separable, right? Integral x is x square by 2. Integral y is nothing but y square by 2 plus c I can write. So basically, if you just simplify and cancel, you'll get x square plus y square equal to c. Now what did he say here? This is interesting. They asked you the solution basically. Now what are they saying? It is passing through 1, 1. It is passing through 1, 1 they said. So actually from here only, without simplifying, they're asking you what is c basically. Right? So if it is passing through 1, 1, what will happen here? 1 by 2 is equal to minus 1 by 2 plus c, right? Everybody? So instead of x, I need to substitute 1. Instead of y, I need to substitute. This is if you want a general solution, but they're asking you value of c. So from here itself, x value 1, y value is also 1. So I'm just substituting that. Take that minus half to the other side. Half plus half. So I am getting c value as 1 basically. So my final equation is x square by 2 is equal to minus y square by 2 plus 1. Or you take it to the other side, x square plus y square equal to 2. Got it? Everybody? All of you? So simple, but what are we doing? This 1 comma 1 which we are applying is nothing but the boundary value condition. The boundary value condition is what we are applying. So in this way, this is also simple. Yes. Now coming to the trick which I told you I will discuss with everybody. Suppose you are getting this. This is not even homogeneous. This is a non-homogeneous type. How do we do this? For this, you have a technique which is differentiate the options. You differentiate the options to get the question. And how do you differentiate? You can use partial fractions, partial differentiation. So dy by dx basically for first option will be minus dou by dou x of x square plus y square plus xy minus 4y minus 2x by dou y of x square plus y square plus xy minus 4y minus 2x. This is how you find out the derivative or dy by dx. And how do you do this, guys? And how do you do this? If you are partially differentiating with x, give a tick wherever x's are there. And other terms, give it a cross. So how do you differentiate this? Derivative of x square is 2x. Cross means it's a constant. So derivative of constant is nothing but 0. Here again, y is a constant. Derivative of x is always 1. And what else is there? This is both are crosses, so again 0. Minus 2 is a constant. Derivative of x is again 1. Whole divided by, again, you are differentiating with y. So for x it's a cross, y it's a tick, x is a cross, y is a tick, y is a tick again, x is a cross. So derivative of y square is nothing but 2y. And this is x is a constant, derivative of y is nothing but 1. So x into 1 we will get. This is minus 4 into derivative of y is again 1. And derivative of 2x, that is nothing but 0. So if you do this, you should be able to take any term common. But if you are doing that, you are observing that is not giving you this. This should exactly give you this. But that's not possible. So you need to differentiate second option and check. You need to differentiate third option and check. Like that, if you keep doing, you will be getting the answer. Is it clear? So I'm using some fundamentals of differentiation and I am trying to get the differential equation basically. So the trick is differentiate options to get the question. You can use any method. I have used partial differentiation method. You can use direct method also. How do you do direct method? Derivative of x square is 2x. Derivative of y square is 2y dy by dx. Derivative of 2xy, you can use UV rule. Like that, separate dy by dx, take it to the other side and solve. So any differential equation, if you are just differentiating the options and you are checking, you will get the answer easy. Is it clear? Everybody please. Are all of you getting it? Are all of you understanding the significance of this? So any question, any method, even this question also you can do it in the same way, guys. Let's check. You know fourth option is the answer, right? Let's check if fourth option is actually by the answer by solving using differentiation. Here I can use UV rule. Y into what is derivative of secant x? Derivative of secant x is secant x tan x plus what is this? This is secant x again. Derivative of y is dy by dx. Now what else is there? C plus derivative of sin x is nothing but cos x. Now you tell me secant x I can take common and send it to the other side. This will become cos into cos. It will be cos square only. So we are getting y tan x plus dy by dx equals to cos square x. Is it clear? So if you are differentiating this, you are actually getting the question. And you can use that for any differential equations. Any method you can use this. Same, even if we see the first question, it will be the same. If you keep on differentiating the option, whatever option is giving you this, that will give you the answer. So am I clear, everybody, regarding the solving of differential equations? Of course, we couldn't discuss it in detail. In Spark Academy's class, we will be discussing in detail all the methods, and we will also be revising, integration also once again. Is that clear, guys? So we learned 3 methods and 1 shortcut method to solve any differential equation. Am I clear? Did all of you get all the methods? So you can solve it by methods or you can solve it by differentiating options. Can I have some comments? Everyone? All of you, please. Vivek, Meghna, Aradhya, Surya, Kyathi, Shreya. I hope all of you are clear with the method. Yes. So this is about your differential equations, and I tried to, due to the time constraint, if you felt that I went a little fast, you can always go back, pause and solve. Right, everyone? Okay, great. Thank you. Thanks everyone for joining the session. Make sure you join the Telegram group. I'll be sharing this PDF in our Telegram group, and you can also practice more questions and you can come back to us with doubts. Thank you once again. If you like this video, do like the video and share it with all your friends so that they also get benefited from it. Thanks a lot, guys, for joining the session, and I'll come up with another exclusive series next week again. Thank you.